Alright, so this is the second part of logic gate video, and in this video we are going to discuss about remaining 3 more gate, and the 4th type of gate is that NOR gate. NOR gate. What is a NOR gate? You can see that the term NOR, there N represent that the NOT and OR represent that OR gate. So when OR and NOT are combined in the series, then formation of the NOR gate. So the representation for the NOR gate is like this. That are the terminal point for the OR gate, and OR gate are represented like this, the curve line, and both curve line are intersect. Then we get the output for the OR gate. So that are the OR gate. Very simple. Okay. So if you take A and B are input for the OR gate, inputs for OR gate, then you get output like this, A plus B. This like a plus sign, but actually that is a Boolean representation. Yeah, we can say that Boolean algebra, right? In my previous video I already teach about that. Right. Alright, so this is the output for the OR gate. Now, but that is not OR gate, that is a NOR gate. So now we combine in a series combination NOT gate. So that is a NOR gate. This output from OR gate and final output from the NOT gate is right. So you can see that this is the output for the NOR gate, but this output is become the input for the NOT gate. So that is a NOT gate, right? And you can see the property of the NOT gate. Property of the NOT, if the A is a input, then the output for the NOR gate is that A bar. So you can see that A plus B is that input for the NOT gate. So we get the final output is that A plus B bar. Okay, so I think Y and Y, so Y dash. Alright, so Y dash is the output for the OR gate, and final output is that Y. Very simple. Okay. So A and B are the input, then OR gate are output like this A plus B, and NOT gate are output like this A bar, A plus B bar, A plus B bar, not A bar plus B bar, right? A plus B bar. Okay, final. And one more type of representation is like this. You can draw a like this, A and B are the input. Okay, and you draw a bubble like shape on the peak point where the output are formed on the OR gate, right? So this is bubble like shape is represent that the NOT gate are series combined with the OR gate, right? So A and B are the input for the NOR gate, then we find the output like this, A plus B bar. Very simple. So that is a representation of the NOR gate. Now we are going to discuss about the circuit diagram. But one more thing is that in the exam never ask about the circuit diagram for the NOR, XOR and NAND gate. So don't worry about that. But I will teach about circuit diagram for the NOR and the NAND gate, right? So this is the representation of the NOR gate. Now we are going to discuss about the circuit diagram for the NOR gate. Alright. So it's very simple. So what happened? It's similar like the OR gate. You well know about that. This type of circuit diagram we draw in my previous video for the OR gate. And that are the bulb in the OR gate, but actually we can we don't take a bulb for in this gate. we take a output as a bulb like this, parallel combination of both switch, right? All right, so this is circuit diagram for the NOR gate, right? Okay, very simple. And I think you never see in your textbook for circuit diagram for the NOR gate. So I think never ask in your exam, just knowledge I just teach about the circuit diagram for the NOR gate. So this circuit is for the NOR gate, very simple. So now we need a truth table for the database of this circuit. So truth table is like this: A, B and output Y. Okay. So every input has two possibility. So there are two input, so we have four possibility. All right. All right. So one more draw column for well explained. That is Y dash. It is a output of OR gate, and that is Y final output is that A plus B bar. It's opposite to the output from OR gate, right? So Y dash is the output from the OR gate and Y is the output from NOT gate. Okay, so this input is become the output, this output is become the input for the NOT gate. Okay, so this is the final output. Okay, so possibility is that when A is on and B is off. Okay, very simple. When A is on and B is off. Okay, so A is on, it means the circuit are complete like this. This circuit are complete, this circuit are complete. Okay, and B is off, then bulb cannot receive the electric signal, right? Okay, so you can see that A plus B is become a 1. I teach in my previous video why this is become 1, right? Then A plus B bar is the opposite of this input. So 1, it means a 0, and if we get 0, then opposite is that a 1. Very simple. So second thing is a 0 and 1, then we get 1, so its opposite is that a 0. And third is that 1 and 1, then we get a 1, so that is a 1, so that is a 0. And fourth thing is that a 0 and 0, then we get a 0 0, then we get a, okay, then we get 0, then we get 1. Very simple. Okay, so you can compare this data from this circuit. Okay, I think you must watch my previous video. You well know about this, how to become data feed from circuit, right? So that is a truth table and that is circuit diagram for the NOR gate. Okay, and I also teach about next is that fifth type of the NAND gate, right? Okay, so all right. So next we go for NAND gate. It's very important for your 12th physics. Fifth type of gate is a NAND gate. What is a NAND gate? Very simple. Similar to the NOR gate, N represent that a NOT and AND represent that the AND gate. So NOT AND gate is that a NAND gate. Very simple. So when we combine in a series combination of AND gate and NOT gate, then we find that a NAND gate. So representation of the NAND gate is like this. Suppose we have the two terminal point that are the input for NAND gate. Okay, and this is output for NAND gate. What is the output? Output is that y dash is equal to a dot dot, it means AND operation b. Alright, in my previous video I already teach about that, y a dot b, and we combine another gate, that is a NOT, and it form a NAND gate. So the final output is that a dot b is output from AND gate, and this output is become a input for NOT gate. So that is a AND gate, and that is a NOT gate. So a plus b is become a dot b is become a dot b bar. So that is a final output for the NAND gate. And another representation are like this. A and B are the input, and a small bubble like shape put on the peak point of AND gate, where the form of the output. So final output is that a dot b bar. So that another representation for the NAND gate. Alright. Okay, so now we are going for a circuit diagram for the NAND gate. Very simple. Circuit diagram for the NAND gate. That is battery, input A, input B, and output bulb. Okay, that is an output. Okay, all right. So well, you know about that. A and B are the input for the NAND gate, and Y is the output for the NAND gate, and output is that A dot B bar. Okay, all right. So now we need a truth table for the data from the circuit. So truth table is that A, B, and Y dash is equal to A dot B, and another final output is that A dot B bar. Okay. If you are not write that column, then no problem, but if you are right, then also no problem. But you know, these are very helpful for understanding this table. All right. Okay. So if the switch A is on, it means the circuit are complete, but B is off. It means this circuit are not complete, but this circuit are complete. So bulb receive the electric signal, so it's a on state. So we put 1. So we put 1 if, listen to me, that is not final output, that is final output. So I put 1 over here, and A is on and B is off. Okay, and A dot B is also we get off, right? Okay. I already teach in this my previous video y is 0, and if A is 0 and B is 1, then we get, listen, B is 1 and A is 0. A is 0, it means circuit are not complete, but there are circuit are complete, but this circuit are the open circuit. So this circuit are not complete. So this circuit are complete. so bulb receive the electric impulse, so signal, so we take a 1 and there is 0 opposite to this, right? And if both are 0, it means this circuit are not complete, this circuit are complete, so we get 1, so there are 0. And if both are on, so switch A on, circuit complete, switch B on, circuit, so this circuit are complete, bulb not receive the electric impulse, so that a 0, so opposite to that it's that a 1. Very simple. So this is the trick for truth table, right? So you can also draw the truth table and the circuit diagram and the representation for the Nand Gate. So that is a Nand Gate. Okay, I hope you got it my point, you well understand from my video. And now last one is the exclusive OR gate, and that is very important for your board exam. So last is that a XOR gate, or also known as exclusive OR gate. Okay, so what is a XOR or exclusive OR gate? So 6 type is that a XOR gate. Okay, so what is a XOR gate and how it's represent, right? So very simple, XOR, it means X is represent exclusive. It actually exclusive is not like that NOT gate, but actually we use the NOT and OR, and also AND gate also are used to form a XOR gate, right? Listen to me, NOT gate, AND gate and OR gate, 3 gate combine to form a XOR gate. So it's known as an exclusive OR gate. Okay, fine. So first we discuss about the representation for the XOR gate. Suppose you have A and B. It is very important, please listen carefully. Then represent like this. Another line, another curve line are draw on the terminal, on the input, and this is the output. It's like that A XOR operation and B. Also we can write like this, AB bar plus A bar B. Okay, listen to me. This is a representation of a XOR gate. Okay, so this is a especially representation for the XOR gate, right? Specific. So now we are going to describe about this XOR gate, right? Very simple. Listen to me. You can see that the output is that A B bar plus A bar B, right? So you can see that first input is that A B bar and second input is that A bar B. Okay, and we use plus. Plus it means a OR gate, right? So OR gate need to plus, and A and B bar are in the multiplication. It means we use a AND gate, because AND gate operation is that a multiplication. And B bar, it means before the multiplication of the AB bar we use for input B NOT gate, then the B input is become the B bar. Okay, and similar we use a NOT gate in the input A, so A become a A bar. Very simple. Listen to me. So you have two input, A and B, right? You need like this operation. So very simple. So first we get AB bar. So A and B are in the multiplication and B are in the B bar. So we put a NOT gate. Then output, then there are the B bar and there are the A, and both are used in AND gate. Then output is like this, AB bar. Very simple. so we get AB bar. Similar, now we have we find for the A bar B. Very simple. So A is become A bar and B are directly to attach to the AND gate. Then we get output like this: A bar B. Okay. Now we have plus sign in both input. So we have input AB bar and A bar B. Now we need a plus sign in both input. So we use a OR gate. So OR gate is that a final input is that a input first is that AB bar plus OR operation, and input second is that A bar B. So that is a circuit that is a representation of the exclusive OR gate. Sometime in the exam only asking about this. What is the representation of the OR gate, exclusive OR gate. So this type of representation is that is known as a OR gate representation. Okay, fine. So now we are going for the truth table. Okay. Listen, circuit diagram never ask in your exam for the OR gate. So don't worry about that. Only truth table can ask, right? So truth table is that A input, B input, we need final output is that A bar B plus B bar A. Also can write AB bar, right? That is the final output, right? So AB, and second thing is that A bar, fourth thing is that B bar, and AB bar, and A bar B, and last one is that AB bar plus A bar B. Okay, are the same AB bar or something, you know. Okay, fine. So first suppose we have A is 1 and B is 0. Then A bar, it means 1 bar, it means 0, and 0 bar, it means 1. So AB bar, A and B bar, 1 1 1, AB bar 1, right? And A bar B, A bar and B, A bar B 0 0, it means 0. And AB bar plus AB bar plus A bar B, it means we get a 1. So that is a first possibility for the OR gate. Second thing is that a 0 and 1. A bar 0 bar, it means 1. B bar 1 bar, it means 0. AB bar, A is 0, and B bar is 0 0 0 0. Alright. And second thing, A bar is 1, B is 1, so we get 1. AB bar plus A bar B, AB bar plus A bar B, so 0 1 1, we get 1. So this is the second possibility. Okay, and the last one is that 1 and 1. A bar, it means 0, B bar, it means 0, because the 1 1 is 0 0. Right now, B bar, A is 1 and B bar is 0. So 1 0 0. Okay, and second thing, A bar is that a 0 and B is that a 1. So 0 and 1, we get a 0. So AB bar plus A bar B is that a 0, we get 0. Alright, and last one is that a 0 0. So A bar is that 1, B bar is that 1. AB bar, A is 0, B bar is that 1. So we get a 0. A bar is that 1 and B is 0. So we get 0. So 0 and 0, we get a 0. So that is a truth table for XOR exclusive OR gate, and we can also known as XOR gate. Very simple, right? So this is your last gate, that is a XOR gate, right? So if you have any doubt from this video and in my previous video, you can comment in my comment box. Definitely I solve your doubt. Okay, thank you for watching this video. All right, goodbye.